So, welcome to the lesson on graphing quadratics. Today, we are going to be focusing in on only one of the forms of a quadratic. There are multiple forms. The main ones that we're going to be covering in this class are the factored form and standard form. Like I said, there are others, but you don't got to worry about them in this Algebra 1 class as of right now. So first off, factored form, standard form, they're very closely related. Last chapter or last lesson, we learned how to actually factor and to multiply polynomials. So if you want to go from factored form to standard form, all you got to do is multiply these two things together. I showed you the distribution method and this Punnett square box method. Box method, a lot of you liked, so I'll just show that right there real quick. You add the common terms, you get your standard form. Okay. Both ways is y equals, but basically you can go from one to the other by either multiplying these together, or if you're in standard form already, you can factor. Again, this is just review of the previous lesson that we did. So what multiplies to be 12 adds to be 7, it must be a 3 and a 4. Since your a is equal to 1, you can just use your shortcut and end up right over here, okay? Main point is that the factored form and standard form, they're basically the same thing. They just look different, but they are the same. One's being multiplied together, the other one you can factor, they go back and forth. Today's lesson is going to be on factored form. Factored form looks like this. It's already factored out for you. So what I want you to do is take a look at this graph. I already graphed it for you. You're going to be expected to graph this thing by the end of this video. But looking at this graph, what do you notice about this graph and this equation over here? So hopefully you were able to see the x-intercepts look a little bit like our actual equation. We got a -3 and a -5, but these are pluses, so +3 +5. So knowing that, if I put x minus 3 and x minus 5 here, what do you think our x-intercepts are going to be? Now, if you said this, you're right. So you got a 3 and a 5. So what did you notice? 3 and 5 are your x-intercepts. So another thing that you might have noticed here is that there's another piece of a parabola that we can see right here, just looking at the x-intercepts. So the x-intercepts are at 3 and 5, and turns out your line of symmetry is right here, right in the middle between these 2 points. So that's one of the properties that we went over in a previous lesson. So line of symmetry you can find from your x-intercepts, all right? So if I gave you this problem, what do you think your x-intercepts would be, just going from the previous ones? So if you got -3 and 1, that's correct. So you had a -1, +1, +1, a +3 was a -3. So x-intercepts at 1 and -3. So it's pretty quick how to find the x-intercepts when it's in factored form. You just take a look at this thing. Some of you might be thinking, oh, okay, so I just switch the sign. Positive becomes negative, negative becomes positive. It's a little bit more complex than that. For our intents and purposes, our problems aren't really going to get much more complicated than this. So you can use that, but that's technically not what's happening. But I'll show you how that's related to each other. So +3 and a -3, and then you have your line of symmetry, also known as the axis of symmetry, right down the middle. All right. So now the next question comes up. All right, so why does that work? So I just told you that you can switch the signs, but why does switching the signs work? I mean, you can't just go around in all your math problems switching signs for no reason. So I'm going to show you a quick reason why these things work, and then from there you can do the quick little pattern that you picked up on. So first off, let's kind of think about what we know about x-intercepts. X-intercepts. So think about what you know about x-intercepts. What do these 2 points have in common? Now, if you came up with y is equal to 0, that's right, because both of these are 0. It's where they touch the x-axis where y equals 0. So that means the same thing. Y is 0 where your graph touches the x-axis. So if I know y is 0 at my x-intercepts, if I want to find them using this equation, I would just take my equation and plug in 0 for y. And then solve that, and you will get your x-intercepts. Now, I haven't taught you how to solve this yet. So let's go ahead and figure out how to solve this thing. So when you plug in 0 for y, you have this equation. Now, we are going to use something called the zero product property. We're not going to get too deep into it because we're going to move on from this form in a couple lessons. But just to kind of build on what you know, don't worry about these two groups. If I know that two things, I don't care what these things are, if two things are being multiplied and they're equal to 0, what do one of these things have to be? Now, if you came up with 0, that's correct. So 0 times anything will give you 0. That's the only way to get 0, is if you multiply by 0. So it doesn't have to be this left one. It could also be this right one. 0 something times 0 is still a 0. Or it could very well be both. Now, the way that we're going to use this is that we're going to take a look at our original equation. These two groups are being multiplied. So again, if two things are being multiplied, one of them has to be a 0 to make a 0. Now, that only works with 0. That doesn't work with other numbers. If this was a 7 over here, you can't say something times something. One of these has to be a 7 to make a 7. That's not true, okay? Or if it was a 12, because these could be anything. It doesn't have to be a 12. So taking what we know, that the 0 product property, anything times 0 gives you 0 back again, we can kind of safely assume that one of these two groups is going to be 0. All right. So 0 times 0 is 0. Something times 0 is 0. Bunch of zeros going on. So basically what's going to happen here is we now can set up two separate equations. We can focus in on this side and we can focus in on this side. So I made it green and red to kind of exemplify that. So either x minus 1 is equal to 0, because this whole thing would be 0, or x plus 3 is equal to 0. So if I think about those two things, now I have two very simple equations to solve. And you probably don't even have to show your work at this point. You can just do mental math if you wanted to. But basically, you add 1 to both sides, you get 1. That's one of your x-intercepts, because I know that's when it's equal to 0. And I subtract 3 from both sides, and then you get your other x-intercept. And then that's it. That's how you find your intercepts. You set each one of these equal to 0 and solve them. They're very easy equations. Now, that's why it ends up being just doing the opposite of that. That's not always true, though. If you have a little number in front of this x, it's not just going to be whatever number's here, so you actually have to solve it out. But like I said, our equations are going to be pretty easy, especially with this distance learning thing going on. All right, so if I take a look at the graph, here's my graph. That's where our points were, -3 and 1. There's your -3 is in green, red is in 1, and that's how you find your x-intercepts. Okay, so with that knowledge in hand, we are going to graph quadratics in factored form. So starting off with the same example that we just did, first step was to find your x-intercepts. So basically, you're going to set y equal to 0 and set up some little mini equations. So your y became a 0. You're going to set up two separate equations, set that equal to 0, and set the other side equal to 0. You don't have to show +1 on both sides. You can just kind of do mental math, but you can do that. And then you have your x-intercepts. Okay, next step is take these x-intercepts, put them on a graph. Okay, you have x-intercepts at 1 and -3, so start graphing it. 1 and -3, put your x-intercepts in right there. Okay, so we took those, put them on our graph. Step 2 is find the axis of symmetry, also known as the line of symmetry. Those mean the same thing. So axis of symmetry or line of symmetry can be found one of two ways. You can either kind of take a look at these points and just kind of see where the middle point is. So 1, 2, 3, these are 4 units apart, so halfway would be 2. Half of 4 is 2, so 1, 2 from there, you're right there at -1. Or you can take the average, -3 plus 1's a -2, average it, divide by 2, you get -1. Either way, you know it's in the middle, okay? That's where your axis of symmetry is going to be, is just right in the middle between those 2 points, right? So that's at x equals -1. Now, next thing we need to find is probably the most important part of our graph, at least one of the most important parts of our graph, is the vertex, all right? Now, what do I know about my vertex and my line of symmetry? I know that my vertex is somewhere on my line of symmetry because the vertex is in the middle of the graph too. So I know this green dot, this vertex, is somewhere in the middle here. I don't know where yet, but I know it's somewhere on here. It could be up here, and then you have an upside down parabola. It could be down here, or it could be right here. It could be anywhere along this line, okay? Line of symmetry, I know my vertex is on there. So what we got to do is we kind of got to nail it down. So we know our x value is a -1 because that's where my line of symmetry is at x equals -1. To find the y value, we're going to use a tool that we used in the past. It's just a table. Just use a table to find that y value. So what we're going to do is we're going to take -1, I know it's -1 because that's my x value. That's my line of symmetry. I'm going to take that. I'm going to plug it into my equation. First, I'm going to write my equation with some blank spots for the x's. Substitute in your x. Simplify this out. So you got -1 minus 1 is a -2. -1 plus 3 is a +2. So it's a -2 times a 2. And I'm out of room. So I'll just put my answer back here. That's -1, -4. All right. So now I know that at -1, -4, that's where I'm going to place my vertex. Okay. So technically, I have enough points to make my graph right now, but I want at least 5 points. I want to see 5 points on your graph. The more points you have, the nicer your graph is going to look. Okay, the more accurate your graph is. So I want at least 5. You got 3 so far. And remember, using the line of symmetry, you get little free points here and there. So I'm going to go ahead and use this table to show where my x-intercepts are. So -1, 2 ways -3, 2 ways +1. Now, I'm just showing this to kind of exemplify the symmetry going on here, because if you notice, both of these are 0. You actually don't need to write into your table anything other than the work you show. So since these points are already on your graph, you don't have to show them on your table. Again, this is just for your kind of viewing to see the patterns happening here. Now, for the extra point, pick whatever point you want. It does not matter, okay? Your domain is all real numbers, which means you get to pick any number you want, but be strategic about it. Don't pick 10. 10 is way over here. That's not even on your graph. Don't do that. Why would you do that to yourself? Don't do that. Okay. What you want to do is pick a value that's very easy to plug in. Probably one of the easiest values to plug in is a 0. Okay. We have not picked 0 yet. We have 0 for our y, but not our x. All right. So we're going to find 2 more points. So we got 0. I'm going to plug a 0 in. So 0 is right here. So now I'm going to figure out where this point's going to end up. So take 0, plug it into the equation. And again, this is just us picking whatever point. You can pick 10 if you want to. You can pick 1,000 if you want to. Just, I don't know why you would. So we're picking 0 because I like working with zeros. So 0 minus 1 is a -1. 0 plus 3 is a 3. So -1 times 3 is just a -3. Okay. So we're going to plot that. 0, -3 is right here. Okay. So just right here is 0, -3. Now, I don't have to plug in anything else because basically I'm going to use my line of symmetry. I said I want 5 points. You can say, hey, there you go, Mr. Gary. There's your 5th point. So now I got 5 points. And there you go. You have enough that you can graph now. Now, just to show you the symmetry on the table, let's go ahead and see where that's at. That would be at -2, -3. And there you go. So see the symmetry going on here. 0's at the end, -3 is right here, 4 is right in the middle. So again, you don't have to draw all of these things on your table when you show your work. You just have to show the parts where you're actually doing work. Everything else was actually just, you saw it on your table. Okay, after you get your points, now you just have to basically draw your parabola. Draw your curve so it hits all of those points. Okay. So again, just a real quick recap. First, find your x-intercepts. You get that one and that one, bam, bam. And then you get your line of symmetry right down the middle. Take that x value of that line of symmetry, plug it in. You'll get your y value. You will get your vertex from that because you'll have an x and a y. Pick one more x value. You could have picked whatever value. You could have picked a -2. You could have picked a not -3 because we already got that one. You could have picked -4, -5, -6, -7, 18, 19, 56, whatever you want. But we picked 0 because 0's just easy. So you got 0 there. We reflect it over, and you got your graph. Okay. If you have any questions on this, feel free to stop by during office hours or email for any help you need. Okay. Take care. Bye bye.